Space sails, also known as solar sails or light sails, are a revolutionary concept in space propulsion that could potentially allow spacecraft to travel vast distances, including interstellar space, without relying on traditional rocket fuel. The idea behind space sails leverages the pressure of photons, particles of light, emitted by the sun or powerful lasers to propel spacecraft. This technology has been explored by scientists and engineers as a means of achieving high speeds and efficient travel over long periods. Space sails work on the principle of radiation pressure. While photons do not have mass, they possess momentum. When they strike a surface, they exert a small amount of pressure. A large, lightweight sail, made from a highly reflective material, can capture this momentum. Over time, with continuous exposure to light, or other electromagnetic radiation, this pressure can gradually accelerate the sail to high velocities. The two main types of space sails are solar sails. These sails harness the constant stream of photons from the sun. The closer a sail is to the sun, the more photon pressure it experiences, allowing for greater acceleration. Solar sails require no fuel, relying solely on sunlight, making them an ideal candidate for long-duration missions within the solar system. Laser-powered sails. For interstellar travel, sunlight becomes too weak to provide significant thrust once a spacecraft leaves the solar system. To address this, researchers propose using powerful ground or space-based lasers to direct concentrated beams of light at the sails. This method could potentially push spacecraft to a significant fraction of the speed of light. The engineering challenges of building space sails involve creating materials that are both extremely lightweight and highly reflective, while also being durable enough to withstand the harsh conditions of space. Some key components and considerations for building a space sail include material. The sail needs to be made of a highly reflective material to maximize photon pressure. Options include ultra-thin films like mylar or Kapton, coated with a reflective metal such as aluminum. The goal is to create a sail that is just a few microns thick, which helps to reduce the overall mass while maintaining structural integrity. Size. To gather enough photon momentum, the sail must be large. Some proposed designs involve sails that are several kilometers in diameter. The larger the surface area, the more photons the sail can collect, leading to higher thrust. However, increasing the size of the sail also introduces challenges with deployment and control. Deployment mechanism. Once launched, the sail needs to unfurl in space. A spacecraft could carry the folded sail into orbit, where it would then be deployed. This could involve mechanical arms or inflatable booms to stretch the sail out into its full shape. Alternatively, the sail could be built in orbit to avoid the complexities of launching a large, fragile structure from Earth. Control. Unlike traditional rockets, space sails have limited control mechanisms. Adjusting the orientation of the sail relative to the incoming light source allows for some maneuverability. By angling the sail, the spacecraft can change its trajectory, though this process is slow and requires precise coordination. Space sail technology holds promise for a variety of space missions, ranging from exploring the outer planets of our solar system to sending probes to nearby star systems. A few potential applications include interplanetary exploration. Solar sails could be used to send small probes to distant planets or moons within our solar system. A spacecraft equipped with a solar sail could gradually accelerate over months or years, allowing it to reach destinations that would be difficult to achieve with conventional propulsion. A well-known example of a solar sail project is the Japanese Icaros mission, which successfully demonstrated solar sail technology in 2010. Interstellar travel. Perhaps the most exciting application of space sails is the possibility of reaching other star systems. Traditional rockets are limited by the amount of fuel they can carry, making interstellar travel infeasible. However, laser-powered sails could be the key to overcoming this limitation. The Breakthrough Starshot initiative, launched in 2016, proposes using powerful ground-based lasers to accelerate tiny, lightweight probes equipped with sails to speeds approaching 20% of the speed of light. These probes could reach the nearest star system, Alpha Centauri, within a few decades. Space observatories. Space sails could also be used to position and maintain space telescopes in precise locations far from Earth. The continuous, gentle push from sunlight could keep a telescope in a stable orbit around the Sun or in a location that minimizes interference from Earth's atmosphere or magnetic field. Despite their potential, space sails face significant technical and operational challenges. Thrust is small, the photon pressure exerted by sunlight is extremely weak, about 9 micronewtons per square meter at Earth's distance from the Sun. This means that while space sails can eventually reach high speeds, the acceleration process is slow, and it takes time for the spacecraft to build up momentum. Material durability. The sail must withstand the harsh environment of space, including micrometeoroid impacts, temperature fluctuations, and radiation. Thin, reflective materials are fragile, and keeping them intact over long-duration missions poses a major engineering challenge. Power source for lasers. For laser-powered sails, the biggest hurdle is generating and maintaining the immense power required to accelerate the spacecraft. A laser powerful enough to push a spacecraft to a fraction of the speed of light would require significant energy and infrastructure, likely involving large space-based energy collectors or ground-based stations with immense output capabilities. Precise navigation. Accurately aiming and controlling a spacecraft with a sail requires extreme precision, especially for long-distance missions like those to other stars. Any deviation from the intended trajectory could result in the spacecraft missing its target by a wide margin. Space sails represent a promising and innovative technology for both interplanetary and interstellar travel. By leveraging the momentum of light, spacecraft equipped with solar or laser sails can achieve speeds unattainable by traditional propulsion methods. Although the concept faces significant engineering challenges, ongoing research and missions like Breakthrough Starshot show that space sails could one day become a reality, potentially ushering in a new era of space exploration.